So if we've got the first one of the blocks is stationary at first. Is that what it said?
One was moving at 9.2, and the second block is originally at rest. Yeah.
Okay, and then afterwards, this one springs back with. So here's our initial. Our final situation is. It just hits. This guy springs back with like 2.5 or something.
Yeah.
Just for a second. And it's asking for the velocity of the second block.
We want the mass of the second block.
Oh, mass of the second block.
Mm-hmm.
And it doesn't tell us the velocity after.
For the second one, huh?
Yeah. Does it tell us the mass of the first one?
Yeah, 4.4.
So the only two numbers it gives us is the 9.2, the 4.4, and the 2.5?
Yep.
Cool. All right, so let me make a note of this.
And the rest, I guess.
Yeah, the 0. So elastic collision. All right, so like you mentioned just a minute ago, we've got conservation of momentum going on, which tells us that initial momentum, good, will equal final momentum. We've also, since it's elastic, we've also got conservation of kinetic energy going on. So kinetic energy initial equals kinetic energy final. It doesn't say anything about friction or anything, does it?
Frictionless. Yeah.
Okay, cool. So that is true then. Great. So momentum is mass times velocity. So initially, all of our momentum is going to be from this first block, because this block doesn't have any velocity. So whatever its mass is going to get zeroed out because it's multiplied by a velocity of 0. So it's momentumless.
Okay.
So our momentum here, though, will be the mass of, let's call that block A, times the velocity of block A. Our final momentum will be a combination of the momentum of block A and the momentum of block B, because now it will be moving. So we'll go ahead and just keep it symbolic for right now. And then hopefully we can save ourselves some headache when it comes to the algebra if we just keep it simple up front.
Yeah, sounds good.
So let's go ahead and solve for one of these. Let's say, let's get VB prime by itself. So we would subtract this whole thing over. So we'd have MA VA minus MA VA prime divided by MB equals VB prime.
Divided by MB. Oh, yeah.
Yeah.
We have to do that. Okay.
So that's how we can get VB prime by itself. We could have done the same thing with VA prime. Doesn't matter.
Okay.
Doesn't look like anything is going to cancel. I guess we could pull out this MA if we wanted to. So we could write MA VA minus VA prime over MB. But that may or may not be helpful. Okay, so let's come over here to the kinetic energy and see what we can derive. So kinetic energy initial, again, is just going to be whatever kinetic energy block A has. Because block B is not moving. So we're going to have 1/2 MA VA prime. The kinetic energy final is going to be a combination. So we'll have 1/2 MA VA prime squared plus 1/2 MB VB prime squared.
Okay, that's good.
So we can make this substitution where we see VB prime. We can put in this term, and it only shows up once. So it's going to look messy for a little while. Hopefully it cleans itself up pretty soon.
Okay, so that last step was just
Substituting this out for VB prime squared. And so that's why I wrote it twice. So
alright.
squared. Okay, so now it looks like we've got 3 variables. We've got mass of B and then mass of A and velocity of A. But it gave us mass of A and velocity of A. So really we only have 1 variable. Let's see if there's any way we can clean it up a bit more before we start plugging stuff in. That might be as far as we can go. I want to say that we'd get some cancellation. One of these MBs would cancel out with one of those MBs. But I don't know if I'm totally confident in that. So I might just want to plug in to this equation. So this is kind of like our master equation. And so now we'll plug in 4.4 everywhere we see MA, and we'll plug in 9.2 for VA and 4.4 for VA prime. Actually, it'd be negative 4.4 since it's recoiling, so it's going back the other direction. So it needs to have the opposite sign as our first velocity. So yeah, let's go ahead and plug that in and then just hash out the algebra. I guess there's no way around that really. So we get 1/2 4.4 9.2 squared equals 1/2 4.4 Oh shoot, it's not negative 4.4, it's negative 2.5.
Alright.
The velocity. Negative 2.5 squared plus. So let's just go ahead and, now that we only have 1 variable, we can just call it M instead of MB, just to save ourselves a little bit of hecticness.